Good morning, everyone. Let's talk about how to determine the equation of a sinusoidal function given the graph. So the first step that you're always going to take with these is to identify what the vertical transformations are. To do that, we're going to start with identifying the max and the min, which are quite obviously 5 and 1. By having the max and the min, we can find the middle, which is the axis of the sinusoidal function. Yes, we can see it easily visually here, but it's good to have math to back it up. So to find the axis, which is halfway through the max and the min, I'm going to average the max and the min. So the axis is 5 plus 1 divided by 2, which gives me 3. Remember that calculators are dumb, and you might need to put brackets in if you are doing this in your calculator. So now I have my middle, my axis. From there, I can find my amplitude. My amplitude is the distance from the middle to the top or the middle to the bottom. I can easily see that here on the graph, that distance being my amplitude, and my amplitude is 2. Or I could take the maximum value and subtract the middle or the axis. So 5 minus 3 is 2, giving me my amplitude. Now I've found my two properties that come from vertical transformations. I'm now on to horizontal transformations. In order to do horizontal transformations, I need to pick a starting point. Now the starting point can occur at the top, at the bottom, or at the middle. And if I'm not told what type of equation I need to give, sine or cosine, then I can pick any of them as a starting point. If I need a cosine function, I need to start either at the top or at the bottom. If I have a sine function, I need to start somewhere on the axis or in the middle. The starting point that I chose is over here at -3, 3, so it's at the middle. The reason that I chose this in the absence of any other direction was I can see one entire cycle back to its starting point on the y-axis if I choose this over here at -3 as my starting point. If I had started at the minimum, I may be making it back down, but I may not be. If I'm starting at the top, I can't see another top, and I'll have to do some extra playing around to come up with a good equation. So this is the starting point I chose. If you notice, it is transformed over to the left by 30 degrees, so that is my horizontal shift, also known as my phase shift at -30. The last property that I need to use is my period. My period being the length of one entire cycle. So that length, based on my starting point, goes from -30 up to 330, which means the length is 330 plus that extra 30, or 360 degrees. In other words, there happens to be no horizontal stretch or compression in this case. But let's look at the math to get what we call the K value that we multiply by inside the brackets. To get the K value, you take the untransformed period, which is 360, and you divide it by the actual period, in this case also 360, and you get your K value, which in this case is 1. Now that we have all the information, we have the axis, the amplitude, we have our starting point, which gives us our phase shift, and we have our period, and we calculated our K value, all that's left to do is substitute all that information into our equation. So, before we do that, though, we need to figure out what type of function we're doing. We aren't starting at the bottom or the top, so it is not a cosine function. We are starting at the middle. That would tell us it's a sine function. But an untransformed sine function starts at the middle and then goes up. Ours starts at the middle and then goes down, which indicates that there is a reflection here. So we are going to have a negative sine function. My final equation, once we've subbed everything in, is negative sine. My amplitude, which is my vertical stretch, is a 2. My vertical shift is +3. My k value, which I calculated, is 1. And my phase is -30, but we have a double negative, so that gives us a positive. So my function, f of x, is -2 sine of bracket x plus 30 degrees, close bracket, plus 3.